Hello and welcome, everyone. Thank you for joining us today for the Kubernetes Autoscaling plus Karpenter does not equal optimization webinar. I am excited to introduce Andy Walton, who heads up sales for Americas at Densify, as well as David Chase, the Kubernetes specialist at Densify. Hey, guys.
Thanks, Daniela. I'm going to get started with a couple slides. I'm going to turn it over to Dave, who's got the deep technical expertise and certifications in Kubernetes. So don't disappoint, Dave. I'm going to build you up here. The problem we see, and just to lead things off around the topic of the whole webinar itself, is there's a whole bunch of tools and techniques, some of them bundled with Kubernetes itself and other ones that are available from third-party vendors. But you will hear terms like optimization and then autoscaling, cluster autoscaler, horizontal pod autoscaler, VPA, event-driven autoscaling, elasticity. And we'll often get questions around with Densifies like, hey, I've got these things, or I'm autoscaling right now. What do I need you guys for? So the whole purpose of this webinar is really to help clear up and describe what some of these techniques are, some of these tools are, and how that differentiates from Densify's offering. So let's just talk about that in terms of what we do from a high level. We are AI-driven analytics, a SaaS-based offering. Our analytics precisely optimize Kubernetes and cloud infrastructure as a service resources to mitigate risk, increase performance, and ultimately reduce costs of the cloud spent around those types of offerings. We do this for Kubernetes wherever it lives, AWS, Microsoft Azure, and Google Cloud. I'll get into a little more details of some of the specifics, but for now, let's turn it over to Dave, and he's going to walk through some of these auto-scaling technologies.
Perfect. Thanks, Andy. Appreciate it. So what I wanted to do is I wanted to start with a bit of an overview of what is autoscaling, what exactly does it mean, what is it, what function does it serve within your Kubernetes cluster. Then we're going to pivot a little bit into how that differs slightly from optimization. And then we're going to continue on talking about how an optimization platform like Densify can solve issues in your Kubernetes environment. But to start things off, let's talk a little bit about what is autoscaling. So it's all about dynamically increasing or decreasing capacity based on changes in demand. So there's two types of different scaling that are available. You may have heard of these two. The first one is vertical scaling. It's also called scaling. This is all about adding additional resources to an existing system. So whether it's adding RAM, whether it's adding additional CPU. This is kind of that traditional IaaS model that you're used to, where you just add more resources to a system again, and this provides additional capacity. But there's also an additional kind of scaling that's called horizontal scaling, and it's also called scaling out. And this is where we add additional instances or add additional nodes in order to add additional parallelism. And we add additional capacity by doing that, adding more instances or nodes. Together, these two auto-scaling techniques provide elasticity. So again, it's all about being highly responsive, that as demand increases for your application, that you're able to maintain performance by adding additional hardware and additional capacity in order to serve that spike in demand, but also at the same time that you have the ability to then, when demand decreases, that we now shrink the available resources so that we're not paying for resources that are going unused. So that's really what the advantage of autoscaling is that it provides elasticity. It's also one of the vital components of a cloud native architecture as defined by the Cloud Native Computing Foundation, the CNCF. So it's something that you're going to see frequently in any cloud native design. But again, we'll touch on this some more. It is a little bit different than optimization, and we're going to go into that in more detail. But first, what I'm going to do is I'm just going to walk through some of the terms that you might have heard from an autoscaling perspective and what they are. So the first is probably the most common type of autoscaling done in a Kubernetes environment, and that is the horizontal pod autoscaler, also known as HPA. The way that HPA works is that when a pod begins to run out of resources, whether that be CPU or memory, horizontal pod autoscaler will kick in and create an additional pod. So again, we're talking about parallelism, adding additional pods to manage that capacity. Often it can scale based on different metrics. The most common are simple metrics like CPU. If CPU is coming close to its limit, then it's going to add additional pods. Same thing for memory. But keep in mind that HPA can be fairly flexible, and any type of metric that you can surface in Prometheus can be used as a metric that you scale horizontal pod autoscaler based on. Now, one thing that's important to keep in mind is that there is a limitation of horizontal pod autoscaler, and that is that the application must be designed to support horizontal scaling. So the vast majority of cloud native apps already support horizontal scaling, but just keep in mind that there are some legacy applications that may not have the support built in. So there might be some environments where HPA is not necessarily an ideal fit. Now, what does this look like? What does it look like in practice when horizontal pod autoscaler is in use? Well, picture this simple Kubernetes cluster where we have a single node and our workload is running a single pod. When that single pod starts to reach its capacity and doesn't have resources available, again, might be CPU, might be memory, horizontal pod autoscaler will just add an additional pod. We've now doubled our available capacity, and it will continue to add pods as required in order to meet demand. And similarly, the same process can work in reverse. It can then, when demand drops, we can now scale down the number of pods we've got available. That way we're not overutilized, or we're not paying for resources that aren't actually being. Moving forward, second type of auto scaling that's available is a vertical pod autoscaler, VPA. This one's not quite used as frequently as HPA, but obviously with two different types of scaling, you have horizontal scaling and vertical scaling. You have a horizontal pod autoscaler and a vertical pod autoscaler. This again addresses that sort of, the traditional sense IaaS role that we're kind of familiar with, where you're simply adding more resources to an existing system in order to provide additional capacity. So with VPA, we add additional memory, we add additional CPU to an existing pod, and by doing so, we add additional capacity to our workloads. Now, there are some limitations with vertical pod autoscaler. One of those limitations is that when VPA goes to resize a pod, it is required that it restarts that pod. If that's a small non-mission critical pod, then that might not have any significant impact. But if it is something that's mission critical, or there's a lot of traffic being driven to, there is the potential that there could be an impact. Some ways to mitigate that is using something called pod disruption budgets that can help minimize the impact of sorts of outages and make sure that you don't have a period where a pod is resizing and you have no service available. So just keep in mind, there are some mitigation strategies there. Another limitation of vertical pod autoscaler is it doesn't have a long memory. It doesn't retain a lot of historical data. So if you have, for example, a monthly job that runs or requires additional resources, VPA is not going to remember that that happens on a monthly basis. And so potentially when that monthly job runs, you may have to resize the pod in order to make available the resources required for it. And lastly, the last limitation I was going to mention was just the fact that because VPA is still an alpha feature, it's not currently recommended for production workloads. So keep that in mind. Now, what does this look like in practice? So similarly to HPA, we start with this very simple scenario where we have a single node and we have a single pod running our workload. But instead of scaling out by adding additional pods, we're scaling out simply by adding additional resources to the pod that's already running in order to increase capacity this way. So slightly different model for how it works. Now, that having been said, in both of these examples, you can see that at a certain point, you're actually going to reach the capacity of the node that you've got available. In the examples we've been using, we have a single node. Eventually, you might run out of resources on that node. That's where cluster autoscaler comes in. Cluster autoscaler is all about adding nodes to your cluster to facilitate continued growth and continued expansion in more capacity. So if you think about it, in many ways, cluster autoscaler allows you nearly infinite capabilities to expand capacity based on incoming demand. The way that it works is it detects when there's a pod that can't be scheduled because none of the nodes have enough room available on them. And cluster autoscaler will then add a node to your cluster, schedule the pod on that node, and then everything proceeds as expected. And similarly, it serves the same function. Once demand drops and there's no longer any workload running on that node, it also then reclaims that node so that you're not paying for hardware that it's not actually in use. Another thing to keep in mind about Cluster Autoscaler, which we'll mention when we get to the next slide, which is Karpenter. One of the features of Cluster Autoscaler is it primarily relies on homogeneous nodes. So that's in the form of scale sets or scale groups, where typically every node, at least within a node group, is exactly the same size, exactly the same type. So that's just something to keep in mind. Now, how does this work? Again, we have the scenario where we have a cluster with a single node. We have our pod running in it. And as demand increases, horizontal pod autoscaler does its job and it continues to add pods. But eventually, we run out of room on this node. This is where cluster autoscaler kicks in. And it provisions an additional node exactly identical to the first one. And we continue to be able to scale within that one. Once we run out of capacity on that additional node, we can continue to scale and add additional nodes to our cluster on top of that. Okay, so a fairly simple concept. Now, fourth method, autoscaling method that I wanted to mention is Karpenter. Karpenter is getting a lot of buzz lately. About a month ago, it finally was released in version 1.0, and it is a direct replacement for Cluster Autoscaler. So similar to Cluster Autoscaler, it's all about adding nodes to your cluster in order to provide additional capacity, but it works a little bit differently. It tends to be faster, it's a lot more flexible, and it's a lot more configurable than Cluster Autoscaler is. It also is much more tied to your cloud service provider, your CSP, and that's why today Karpenter, for the most part, is synonymous with AWS. But there is a version available for Azure right now, and other cloud providers are likely to follow very shortly. One of the things that's unique about it is that it follows a just-in-time provisioning methodology for nodes. So what that means is when it detects that there's a pending workload, a pod that needs to run, but there aren't sufficient nodes, it then goes out and it selects the best node type in order to fulfill that request. So you're not tied to these homogeneous scale groups where everything is the same. Karpenter actually has the intelligence to match the best node type for that workload. It also supports spot instances. So it does allow you to save significantly in costs by leveraging spot instances, where you can see, I've heard many different numbers, but up to 75% savings in a spot instance is available. So that's one way that it can help you to save within your environment. But there are some limitations. A couple of those limitations are, first of all, it can only recommend node types that you've made it aware of. So when you set up Karpenter, you're configuring what's called a node pool. You tell that node pool what are the node types that we will allow, and it will then select the best fit based on those available nodes. However, if you're not specifying the appropriate node types, then that's a potential limitation. And another issue is that Karpenter cannot resize pods. So with Karpenter and with all of these auto scaling options that we've discussed, one of the biggest limitations is if you set requests and limits for your workloads that are wildly out of whack, you're requesting 2-3 times the amount of resources required for a workload, then when it starts to scale up, it's going to scale up the inefficiency as well. So you want to make sure, you got to keep in mind that pod and node optimization is also important, not just the ability to scale up and down for elasticity. So how does Karpenter look? Again, very similar to Cluster Autoscaler, but once we get to the limits of one particular node, we scale out to an additional node. This node doesn't have to be exactly the same. It could be a different size. It could be an on-demand node. It could be a spot instance. And same thing with once we run out of capacity on that node. So it can continue to scale out, add additional nodes for you, but these aren't tied to being identical members of scale set. You have the ability to provision the appropriate node type. Now, I wanted to just quickly touch on 3 other auto scaling options. I won't go into them in any great detail, but there is something called event-based autoscaling. So it works in conjunction with horizontal pod autoscaler. The most popular product that works as an event-based autoscaling is called Kita. It's the Kubernetes event-driven autoscaler. And what it does is it allows you very easily to scale based on application events. So instead of scaling just on something like CPU or memory, you're able to scale on something like how many messages are waiting in a message queue, or how many web requests are we receiving on our web applications. So you get a much more potentially intelligent scaling methodology here. Another option is schedule-based autoscaling. If you have very predictable usage patterns for your application, let's say it always sees a spike in use on the same day of the week, or perhaps it's at the same time of day, every lunch, you see a spike in demand, you can autoscale based on a schedule. One of the advantages of doing that is that if you know that lunchtime is when you typically see a spike, you can start scaling prior to that because there is some latency involved in adding pods and adding nodes to a cluster. So schedule-based autoscaling allows you to pre-scale and therefore avoid that latency. And lastly, we have container startup autoscaling. I won't go into this one in great detail, but just keep in mind, there are some containers that require more resources when they're starting up versus once they hit steady state. So there are some options, including an option from Google that allows you to autoscale and or provision additional capacity for that pod while it's starting, but once it's reached steady state to then reclaim some of those resources. That having been said, now let's tie it back to a little bit more about how does this fit in with Densify and how is autoscaling different than optimization? So the question we received a lot is, well, which one of these should I use? Should I be using cluster autoscaler? Should I be using horizontal pod autoscaler? Or another question that I've received several times is, should I be using Densify or should I be using Karpenter to optimize my environment? And the answer is that they're not mutually exclusive. So they're all different solutions to different problems. And in pretty much every environment, you're going to be wanting to use a mix of the autoscaling options and also have optimizations part of the mix as well. So it's not an either or decision. It's making sure that you've tailored your approach for your environment. So is autoscaling the same as optimizing? Autoscaling, keep in mind, is all about elasticity. It's about responding to changes in demand patterns and providing the right amount of capacity so that your applications remain performant, you have good response times, but also that you then respond to drop in demand by deallocating any hardware that you don't require long-term. Densify is all about optimizing your workload. So making sure that you set the right requests, the right limits, that your node sizes are all appropriate for your workload to make sure that you're not wasting capacity. The two capabilities are compatible. So Densify is perfectly compatible with all of the different autoscaling options out there, and they're also complementary. If all you're doing is autoscaling, but you haven't optimized your workloads, let's say, again, you've got a pod where you're allocating 3 times more memory than it actually needs, autoscaling is just going to happily go ahead and provision more hardware. And in the cloud world, hardware and money are the same thing. You want to optimize your workloads to ensure that you're not scaling out to a far greater capacity than what you're actually going to be utilizing. So you need to do both. Have elasticity in your environment and also be doing optimization. At this point, I'm going to hand it back to you, Andy, for a few minutes to go into more detail about how a full stack K8 optimization platform like Densify can help you in your environment.
Great. Thanks, Dave. I'm actually going to keep you on the line here for 1 second. I see a question in the panel, and I'm going to ask it now because we're talking. Is HPA used, say, 80%, 90% of the time? Seems VPA is not preferred as it deals with legacy apps. Is this a correct assumption? What's your take on that?
My take is that HPA is by far the most popular autoscaling technology out there. VPA is not utilized widely. I think it's primarily due to the limitations that I listed. Having to restart a pod in order to allocate additional resources is a big downside. The fact that it's still in alpha, not recommended for production workloads, is a big downside. So I think that what we see in the field is there are far more customers using HPA. They don't necessarily use it on every single workload. Not every single workload necessarily needs to scale, but where you do need to have that flexibility and elasticity, HPA is the way to go. And then again, cluster autoscaler is also absolutely vital because you don't want HPA scaling out to a ton of pods and then realizing that you run out of space on your nodes. That's where cluster autoscaler comes in.
Right. And it would seem to me VPA, like you say, you're restarting a pod at the worst possible time when it needs more resources. You mentioned there's some mitigation around that, but that does not sound like the right time to restart an app. It is when it needs the most it's asked for. Anyhow, hopefully that answered the question. We'll just dig in one slide here a little deeper on what Densify does. We are full stack Kubernetes resource optimization. We do deep analysis of the containers, pods, replica sets, and the deployments. And this view here, we call it basically it's a histogram. It's an at-a-glance view of the under and over provisioned resources in the environment. In this case, you're seeing the CPU and memory requests and limits. Anywhere where you see a lot of yellow, it basically means, wow, you really over provisioned the environment. In fact, that gigantic yellow line there on CPU request is actually showing the containers in that environment that are 5 times over provisioned. So 5 times the amount of CPU that's required. And anywhere where you see a lot of orange, like in memory request, it's showing you shortfalls, areas where you are at risk of the pod getting terminated because it does not have enough memory. So from a high level, this is a great view as to how well the environment is configured. But then we go to the next level, which is essentially now specific visibility into each and every container in an environment, where we can rapidly identify savings, areas out of memory risks, memory limit issues. We'll actually list those things out. And not only that, not just provide the visibility in the areas where, we've got restarts, et cetera, but providing the exact settings, recommendations to set those CPU and memory requests and limits correctly, as well as the whole predictive workload pattern over a 24-hour period of what we anticipate those workloads are going to do for every single container you have running. And then finally, we also not only look at the request and limit recommendations for the containers themselves, but also at the nodes that infrastructure is running on. So this is, again, why we call it full stack resource optimization. The ability now, because where the spend happens is actually at the node level. So by fixing those resources correctly, we can deploy the right number and the right type of instance families for the nodes. In this case, this is an example, and it's a small example, but looking at the autoscaling groups running in AWS, are you running on the right instance? Do you have the right number of minimum and maximum number of nodes in that autoscaling group? So we look at that, analyze that, and set that correctly. Again, full stack optimization across the environment. And so that's what we do. And hopefully that gives you a better idea of our capabilities versus the complementary features of a lot of that autoscaling technology that Dave has run through today. Would you like to try it out? We have a rapid experience, a 30-day trial for customers with 2,000 or more pods. If you don't have that much, then there may still be a fit, but typically customers that have an environment of that size now are looking for some technology to help them right size in a more automated fashion. We'll uncover the potential for the platform owners, which is really looking at those out of memory kills and areas where we've got restarts and mitigate that application risk. And from a FinOps perspective, the ability then to reduce the cloud spend as we fix the resources in the Kubernetes environment. We will also look at the nodes that stuff is running on and look for actual cloud spend reductions. It uses Prometheus, so you need Prometheus installed in your environment. The setup, if you've got that already, is about an hour to set it up. We've got a small container forwarder that sits in there and talks to Prometheus, sends your data up to a dedicated instance in the cloud. So real simple to do. 30 days, give it a try and see what you think. If you like, go to our website and download the GigaOM report. You can also scan it if you've got your cameras available right now. We're named a market leader in the GigaOM radar report for Kubernetes resource management. So you get an idea to look a little more detail of third-party assessment of how Densify works, as well as other competitors in the environment and how do we compare to them. So I think it's a great report and have a look at that. And finally, if you're going to be at KubeCon in November in Salt Lake City, we'll be there. So we'd be happy to speak to you in person. That's a great event. I do have one question, Dave, and we'll get you to address that. Do you have a suggested approach on what to optimize first? I kind of alluded to it, but I'll let you answer in a little more technical basis.
Yeah, so usually what we recommend is that when you're looking to optimize, start by finding the risks in your environment. So the parts of your environment where you're not allocating sufficient resources for them. As you showed in your slide with the red bars, you can very easily spot those using Densify. Focus on those first, because that's where you run into potential risk of pods being terminated or out of memory events taking place. So address those first. Then address waste, address any circumstances where you're allocating too many resources for a pod, and that's where you can achieve some of your cost savings. It also will make your cluster more healthy. So addressing risks is important from a cluster health perspective. Addressing overages is very important as well from a cluster health perspective, as well as a savings and optimization perspective. And then the third step, once you've got that under control, is then look at your node optimizations.
Just to add to that, I think it's important, you really do have to consider what order you do those things in. We've seen some bill readers that are out there that immediately are attacking the nodes without any understanding what the underlying Kubernetes infrastructure are on that. So you can't right size a node without first right sizing the resources that are using that node, right?
Exactly.
Great. Well, we've got links here. You can follow us on all the socials, as well as our website, which has been recently updated with all kinds of great information. Dave, thanks very much for the insightful commentary on autoscaling. It was great. And we'll look forward to seeing you at KubeCon and at the next webinar. Thanks, folks, and have a great day.